Okay, so now we'll be talking about monitoring with geotechnical sensors. So basically, we have two types. We have the measuring and monitoring. So measuring is done. So measuring is done in a static environment where the observations are done for one time. On the other hand, during the monitoring, we are reading the same target for a long period of time to be sure that it's not moving. The environment will be changing each time we make the observation because there will be some difference in some parameters like temperature and pressure. So at the same time, as we talked in the part 1 and part 2 of this webinar series, we spoke about having a region of influence to monitor. So basically we have two cases. In the first case, we know already that, for example, there are some construction near a building, and this will have an impact on the building. So generally, before the start of the construction, we set the baseline, which is our reference measurement, and start monitoring during the construction of the project to check if there is any risk or any displacement. In the other case, we know already that there is some movements, so we fix our baseline as soon as possible and start monitoring to check the behavior and check if there is any risk or for the displacement. So in the next slide, you see that we have previous slide, please.
Oh, sorry.
Yeah. So yeah. So yeah, in this slide we can see that there is some construction around those buildings. So we already set the monitoring geotechnical devices on the building to monitor if there is any movements. And in the next slide, we see that we have already some movement. So we need to fix the geotechnical sensor on the building as soon as possible to check if there's any risk for this displacement. Okay, so now we'll be talking about automated geotechnical monitoring. So for automated geotechnical monitoring, you will basically need the geotechnical sensors that will be placed on site to collect the data, and the gateway to send the sensors data through the internet to the visualization or processing software. So at Trimble, we offer an automated monitoring solution, which is T4D control, which is easy and fast to install and set up, with long-range radio communication, long battery life, and it's durable. So how does it work? So all you need is a sensor that can communicate directly with the gateway, or a sensor that is attached to a data logger that will communicate with the gateway. Later, the gateway will send the data to T4D web, where we can visualize and process the data. At the same time, there will be like many things to consider during the installation of geotechnical sensor and the setup. We can see in the next slide. For an automated geotechnical monitoring system, you will need to consider the compatibility of the sensor with the data logger and the gateway at the same time with T4D. You will also need to check the power source, how the system will be powered using the solar kit, batteries, and the required sampling rate. You need to check also the installation location and height to ensure the good communication between the devices and the internet connection to the gateways. It should be like using 4G SIM or Ethernet cable, and the data transfer. So we will be talking first about the compatibility. We always need to check the compatibility between the sensor and the data logger. So we have the vibrating wire data logger, which is a low power consumption 5-volt multi-channel or a single channel. It is IP67 with an external antenna. It can read any sensor working with 300 up to 7,000 hertz. The raw data is normally in frequency or ohm, and it will be converted using formulas to kilopascal or meter above sea level or temperatures. We have the analog data logger. It can power sensor from 5 volt, 12 volt, 24 volt up to 60 milliamp. With 4 channels and external antenna. It can read the outputs from the sensor like the voltage, current loop, thermistor, and PT100. At the same time, we have the Pico node. It is very similar to the analog data logger. The main difference is that is only with only one channel. It's used with low power sensor, like 5 volt up to 50 milliamp, and it's IP67 with an internal antenna. For output readings, it's very similar to the analog data logger with a pulse sensor that can be used with ring gauges. The digital data logger is mostly used by a weather station and MPBX, multi-point borehole extension meter, and IPI in-place inclinometer. Now we will be talking this slide is showing as you can see in this slide, we support a wide range of sensor manufacturer. So at the same time, a wide range of different types of sensors. Talking about battery life estimation, we should know that the battery life estimation is based on 2 factors: the number of battery cells installed in the data logger and the sampling rate. If the sampling rate is high, you should know that this will drain the battery faster. Talking now about communication, as we see in those charts, we will have a longer communication range in a rural environment because we will have less obstacles, and at the same time, the range will be extended when the gateway is placed at a higher place. The next slide shows that the gateway is installed on the top of the building, to be sure the communication between the devices is pretty good.